Hello, everybody. This is Mr. Carpenter, and this is Easy as Pie with Mr. Carpenter. And in this, I will be walking you through your Algebra 1 equations exam review. So whether you were not here to look at the review, or you completed it but you missed one, or maybe you just want a refresher on the step-by-step process for these kinds of questions before you take your exam, that is all going to be covered here. So let's get going. Number one, to solve the equation 2x plus 6 equals 10, your first step would be to what? And this might throw a couple people off because there are technically two first steps, right? If I write this equation out, there are two problems here, right? Everything on the same side of the variable is a problem because we want our variable to be isolated. So in this case, the plus 6 is a problem. So I would do the opposite of adding 6, which is subtracting 6 from both sides. And that, in this case, would be the answer, subtracting 6 from both sides. But you could say, Mr. Carpenter, I could also technically, that eraser is a little big. Mr. Carpenter, I could also technically divide every term by 2. And that would also be a viable first step. And you are absolutely right. So now, in this case, we'd have to do a little bit of logical reasoning here, right? If me, the test giver, knows that there's two steps that you could start with, I would not put them both as a multiple choice answer, right? So you're not going to see divide both sides by 2 as one of your answer choices. And also, we've always emphasized that when we're in this two-step equation, that we like to add or subtract before we multiply or divide to avoid mistakes. So only one of those two potential first steps is an answer, and it is, of course, the one that we have been stressing this whole time regardless. So we are going to subtract 6 from both sides. Number 2, the formula for the area of a trapezoid is A equals, the area equals the height times its first base plus its second base, which I represent as x and y, and then I cut that in half. And I want to rewrite this equation to highlight my height, which means I want the h variable by itself. And this looks like a daunting task, but once you take it one step at a time, you'll realize that your work is really laid out for you. Our first step here is recognizing that my h variable is never going to be by itself if it's stuck in a fraction. Fractions are very gross. So our first plan of attack is usually going to be to get the fraction out of there. And we're going to take care of that by multiplying by the denominator, right? Because this term here is being divided by 2. And the opposite of dividing by 2 is multiplying by 2. Please do not forget that what you do to one side, you must do to the other side, right? So on the left-hand side, I will have 2 times a. And on the right-hand side, right, this term here is going to get multiplied by 2, and then it's going to divide by 2. So the 2's will cancel out, and I'm just going to be left with my numerator. And then, once again, do not overthink these kinds of steps, right? H is being multiplied by that number, right? The fact that you don't know what that number is does not change the fact that the opposite of multiplying it by it is dividing by it. Your thought process does not change. It just gets a little more abstract. H is being multiplied by this number, x plus y. And the opposite of multiplying by that number is dividing by that number. So those variables will cancel out. And h will be equal to 2a divided by x plus y. I do not know what 2a divided by x plus y is because I don't know what any of those variables represent. So I'm not going to do more work than I have to. And I have a final answer. Okay. Number 3, we're building an equation here. So Olivia is an aspiring artist whose notebook is already filled with 58 drawings. And she adds 2 more drawings each day. When her notebook has 200 drawings, it will be full. Which equation accurately represents how many days it will take her to fill the notebook? First, we need to identify what it is we don't know. And in this case, we don't know how many days it will take to fill the notebook. We will let X do that job. Now, in order to do this, we're going to have to build an equation. And in this equation, I'm going to have two expressions representing how many pages are in this notebook, right? So on one hand, on the right-hand side, I know that there's 200 drawings in the notebook, right? The whole notebook can fill up to 200 drawings. And on the left-hand side, I can write down what's actually happening, right? We have 58 drawings already, and we're adding 2 more drawings each day. When you see this word each, or maybe you'll see the word per day, in both of those cases, I want you to think about multiplying, because that's kind of like a buzzword for multiplying, right? 2 drawings each day, 2 drawings per day. And I let my variable X represent my number of days. So it's going to be 2 drawings per day, 2 times X. And I'm going to add in those 58 drawings that I already have, right? And that is how I get answer D in this problem. I have built my equation. Notice I'm not asking you to solve it. I just want to know which equation represents it. Then we get to number 4. You knew this part was coming. Just some good old get down to work and solve some equations. So allow me to walk through these now. This is a 2-stepper. I will number them for brevity's sake. That first one is a 2-stepper, right? So there are 2 things that I have to do. One of those things is this minus 10, right? So the opposite of subtracting 10 is adding 10. And once again, if you feel this line is necessary and helpful for you, then please do it. Because the last thing that I want to see is something like this, where you're accidentally adding 20 to the one side of the equation. And now your proverbial scale is off balance, right? So drawing that line shows me that this plus 10 has to occur here, and it has to occur there. Those cancel out. Carry everything down I did not touch. 2x equals, and 30 plus 10 is 40. Then the opposite of multiplying by 2 is dividing by 2. And 40 divided by 2 is 20. Perfect. Number 2, x divided by 3 minus 4 equals 2. Now, once again, in these 2-steppers, we're going to try to add or subtract before we multiply or divide, right? Now, if we were in the situation where the whole side was being divided by 3, right now we're in a bit of a pickle where we have no choice but to get rid of our fraction by multiplying everything by 3. But since these are 2 separate terms, right, separated by a minus sign, I can comfortably get rid of the minus 4 and then take care of my fraction, right? I want my fraction to be the only thing on one side of the equation before I take care of it. So let's add 4 to both sides, because that's the opposite of subtracting 4. And we'll get x divided by 3 equals 2 plus 4 is 6. Now my fraction is all by itself, right? And now I can get rid of my fraction by multiplying that term by 3 and that term by 3. 3 times 3 is 1, so let's cancel out. And 6 times 3 is 18. Perfect. Number 3. Now we're going to get into these situations where we go through that 3-step process, where it doesn't look like one of these nice ones here, where we kind of already have our grounding beneath us. So my first question is, can we distribute? And in this case, we can distribute, right? We can distribute the negative 10 amongst all the terms inside the parentheses, right? So negative 10 times 2x would be negative 20x. And negative 10 times negative 3, do not forget about that negative sign, is going to be a positive 30, because a negative times a negative is a positive. And please do not be afraid on a test to put these kinds of things in your calculator, right? Your calculator is not some kind of, you should not feel guilty for using your calculator, right? It's a tool. And one of the things that you learn in school is how to use tools to your advantage. So use your calculator to the greatest extent of its capabilities, right? Now that we've distributed, this turned into something that we know and love, right? It looks more similar to those there, right? Those two-steppers. So the opposite of adding 30 is subtracting 30. Those cancel, and negative 20x equals 10 minus 30 is negative 20. And then the opposite of multiplying by negative 20 is dividing by negative 20. And negative 20 divided by 20 is positive 1. And we're done there. Number 4, first question, can I distribute? And the answer is yes. Right? I know you guys immediately see this and want to jump in. And there's not too much stopping you from doing it. It's a pretty harmless step. But I find just consistency in the steps every time gives you less work and not more. And you'll see why in a moment, right? So we distribute. Let's carry down these two terms. Positive 5 times x is positive 5x. And 5 times negative 2 is negative 10 equals 55. Now that I've distributed, I can ask myself, can I combine like terms? And the answer is yes. These terms all share the same variable, and they're on the same side of my equation, so I can combine them. And because I distributed before I combined like terms, I discovered this like term there that I could combine with them, and it saved me a step, right? Otherwise, I would have combined those like terms, and then I would distribute, and then I'd have to combine like terms again, right? The more steps you do, the more potential for a mistake. But we combine like terms. 2 plus 6 is 8. 8 plus 5 is 13. 13x's minus 10 equals 55. And once again, we were at a two-stepper, right? Very comfortable with these. Opposite of subtracting 10 is adding 10. So 13x equals 55 plus 10 is 65. And then the opposite of multiplying by 13 is dividing by 13. And as gross as that fraction looks, 65 divided by 13 actually is just 5. So we are done. Moving on. Number 5, it is very tempting to combine like terms right here, but you have to remember that if they are not on the same side of the equal sign, they are not like terms and therefore cannot be combined. What we instead have to do is we have to cancel out one of our variables, right, by doing its opposite. So over here, there's a negative 4. The opposite of subtracting 4x is adding 4x. And in doing so, I reduce myself from 2 variables to 1, right? One variable cancels out and scoots over to the other side. And of course, I strategically picked to cancel out the negative 4, so that way I'd have a nice sunshiny positive coefficient to work with. So I add 4x to both sides. 6x plus 4x is 10x. Let me carry down everything else. And now it's a two-stepper, right? Opposite of subtracting 15 is adding 15. So 10x equals 5 plus 15 is 20. And then we just divide by 10, right? Because the opposite of multiplying by 10 is dividing by 10. And 20 divided by 10 is 2. Last one for this section, it is another literal equation. It is a very nice literal equation because it's only one step, right? I want x by itself, but it is being added to 2y, right? So the opposite of a positive 2y would be a minus 2y. And what I do to one side, I must do to the other. So 2y minus 2y is 0. That cancels out. X is all by itself. And it's very tempting here to say that 12 minus 2y is 10y, but you cannot fall into that trap, right? If they do not have the same variable, then they are not like terms. You can't add them together, right? So for this, you just kind of have to bite the bullet and say, I don't know what 12 minus 2y is. So I'm just going to leave it as 12 minus 2y, right? Don't overextend yourself. Do more work than you have to. And then lastly, this is that breaking even business model question that I alluded to in our last lesson before the review, right? We're breaking even if our expenses are equal to our revenue. So the money that we spend is equal to the money that we make. And now we're looking at the super fun bounce house company, right? And we're going to write an expression to represent their expenses and their profits. Or in this case, you could also think of their profits as actually a better word would be revenue, not profits. Let me fix that real quick. Okay. We're setting X equal to number of customers, because that is what we do not know. We don't know how many customers we're having in our super fun bounce house. So an expression to represent our expenses. How much are we spending, right? And an expression doesn't have an equal sign, right? It is just a collection of terms. So what are we spending? Well, we're spending $10,000 to rent out the space, right? So we're definitely spending $10,000. So that should definitely be in my expression somewhere. And it also is going to cost me $5 per, once again, notice up here, each day or per day, we think about multiplying. It costs $5 per customer to operate the bounce house, order food, and pay staff, right? So if there's only one customer, it would cost $5. If there was 2 customers, it would be 5 times 2, it would be $10. Okay? And this is my expenses, right? I'd spend $10,000, and then I also spend an additional $5 per customer. For my revenue, right, what money am I bringing in? I'm bringing in $15 per customer. $15 per customer times the amount of customers that come into my bounce house. Okay? And then we set these two expressions equal to each other and we solve. How many customers does the business need to break even? So my expenses need to equal my revenue. And now it is a two-step it is a two-step equation, but not the two-stepper that you know and love, right? Because I have variables on opposite sides. So I have to cancel out one of my variables. So the opposite of plus 5x is minus 5x. So carry everything else down, 10,000. And 15 minus 5 is 10x. And the opposite of multiplying by 10 is dividing by 10. And so it will take me 1,000 customers in order to break even. $1,000 customers to break even. And I'm done. So that is it for this review. Please, please, please do not hesitate to email me if you have any questions, comments, or concerns. And thank you for watching.